Oh, but you would also have a cosine in there. See, if you pick the squared, then you're going to drop the 2 out, cosine x, then negative sine x. So you're going to have the same problem we would have had if we picked 1 plus cosine squared. Understand?
Yes, sir.
So this is that delicate balance between picking, too much and not enough. Okay? So I'm going to multiply both sides by negative 2. And this times negative 2 gives me 2 sine x dx. So I should be able to rewrite this integral now, right? All right, should be integral, let's see here. The 2 sine x dx, all that is going to be replaced with negative 2 du. And then I have left 1 over root 1 plus u squared du, right? Now, that is something. Go to your formula sheets. Which formula is that?
Inverse sine hyperbolic.
Is it? I'm trying to look at the formula here. There it is. Yes, formula number 31 on reference page number 5 shows that the derivative of the inverse sine hyperbolic function, is 1 over the square root of 1 plus x squared. So this would have to be something that you recognized from your derivatives. So this would turn out to be, I still like that. This would be negative 2 out front, and then you would have inverse sine hyperbolic of u plus c. So there's no work to be done there. And then you just replace u with cosine x, and we're done. Like I said, this test was a little bit harder. I think that step right there is a little bit difficult because you have to know the formula. This step, not so much. This is a basic u sub right there. Okay. Do you want me to stop calling on you? 1, 2, 3, 4. Where's Adam?
That's me.
That's you. All right.
He's like, yeah, we should stop.
And Adam's going to get, drum roll. All right. So let's let Adam think, all right? Are y'all finding this helpful at all? I mean, I hope it is. It's y'all keep on asking me, could you do this? Should I do that? Just tell me what to do. I'm going to write.
Okay, say u is 2 plus x.
Okay, u is 2 plus x.
The derivative of that would be 1. Set x equal to u minus 2. So
This is correct. Keep going.
So
Can I recap just as you think, as you sit there and this dx is du, right? And 2 plus x is going to be u. And the only thing you need to deal with now is the x squared. And it looked like you were on your way to figure out what x squared was because you solved for x. Square both sides. All right, so when we square that, we get that, right? And guess what we need to do with this?
not foil.
No, foil it. We get to foil it, right? Okay, I'll do that later. Well, do we have to foil it? Let's see. Let's rewrite. This is u minus 2 squared. That's the top. Over what? Root u, and then du. So you may look at that and initially be like, crap, what do I do with that? But I kind of gave it away just now by telling you what we need to do next. If you FOIL out the top, you're going to have multiple terms, right, of u? And then the bottom is just a single term, and then you just each one separately. Okay, u squared minus 4u plus 4 over root u du, and then split up, and then do each one, power rule on each one, right? And then once you're done, go back up, and don't forget to replace all your stuff. All right, let's see who's next. Man, this thing, I don't trust this generator. It keeps bringing up the same names. How about Bianca? Hey, how you doing, Bianca? Doing good? Everyone gets all nervous. So are you are you more nervous because you don't want to embarrass yourself in front of the class, or are you nervous because you're not nervous? You're not. You're nervous? Okay. Let's see if I'm nervous for you. Hold on. Some of these we can't do, okay? Some of these we can't do. Let me just look at this one real quick and see if we can do this one. Yeah, Bianca, we can do this. So, do you have like a gut instinct right now of just like, do this? Yeah, go with it. Okay, good. All right, so you said you think you want to. I'm not quite sure what makes people think what they need to do. But that instinct is the correct instinct to have here. All right? So if that's what your instinct's telling you, go with it. Let's see what happens. The derivative of this is 2x dx, right? Now you do not have a 2x dx. But what can you do? So, this one right here, right? You can split that as an x squared times an x, can't you? And then on the bottom, you still had this x squared plus 4 to the 3 halves, and then the dx. Bianca, the ship is sailing here. We are good. This right here is going to be u, right? This x dx is right here. We do have that 2 to worry about, right? So we can just multiply both sides by a half. 1/2 here, divide here, it's gone. The only thing left, Bianca, is, this is going to turn into something, that's going to turn into something, so you have to deal with that. So what's that? Go back up to your, there you go. Yep, you can solve this for x squared. U minus 4 is x squared, right? Okay. So let's see, let's rewrite everything. We have this x squared taken care of, that's this. So we get x squared, which is u minus 4, over u to the 3 halves, and then x dx, this part right here, is 1/2 du. Bianca, you have 2 terms, and you have a single term. Split, right? And then rewrite these as powers of u, and then integrate up. Okay. Where's Adam at? Oh, wait, hold on. There's 2. Okay. What's your last name?
Hooker.
That's right. So you're Adam Brunkhorst. Well, look, you volunteered, Adam, so we'll go ahead and it came up with you twice. I don't know what's going on up here. We're getting... All right. How are we doing on time? We still have 30 minutes. Okay, we're on number 4 on this test. I believe there's only 8 problems on this test. Now let me look at it first. Yeah, this one we can't. We can do this one, but I wouldn't give you something like this on the test because I have not given you anything like this at all. But I gave it to my Spring 15 class. But I'm sure I'd given them something similar to it at some point in time. Do you see how different this looks? Doesn't this look very different than anything we've done? I mean, if it was just x squared on the bottom, like we'd be happy, right? We can split it up. But it's not. And so do you want me to do this just to show you, or you want me to just move on? Because I'll show it to you, but I won't test you on anything like this, all right? So what we do here, we first make sure we can't do any sort of factoring and cancel factors, which we can't, right? We can't cancel anything here. So what we could do is we could do long division first, because you have a polynomial divided by a polynomial. Y'all sure you want me to show you? So I write x cubed here plus 0, yeah, minus x plus 3. Well, doing long division in an integral is something we're going to have to do later. Like, this will come up. It's not like we're never going to see this. So this is how we would attack this. We just go numerator, right? Now I put a 0x squared here because when you do long division, you have to leave spaces for things you don't have. And then I just start playing my little game where I figure out what I multiply this by to get that. So I need an x. And it doesn't matter where you put it. Some people are like, put it right above the x. Doesn't matter, just put it here, x. Now that x goes and multiplies times everything here. So we get x cubed, we get x squared, we get minus 2x. And then you have to come through and change the signs, right? So you subtract, this turns into a minus, this one turns into a plus, and then you add down. So what happens when I add down? What do I get? Get x here, and then plus 3. And then what do you multiply x squared by to get x? You don't, right? You don't. So now that's your remainder.
Man, I'm sorry, don't you get a negative 1x squared?
Yeah, because it's 0x squared minus x squared. So
Oh, did I? Oh, I forgot this one. Yeah, sorry. Negative x squared. Thank you. Okay, so yes, I can keep going. Sorry. All right, let me just, yeah. This one right here gives, this is like minus 1 of these, plus an x, plus a 3. Okay, so now, what do you multiply x squared by to get negative x squared? Negative 1. And then you just multiply the negative 1 through there, you get negative x squared minus x plus 2. And then you come through and change the signs. This becomes plus. This becomes plus, this becomes a minus. And now add down again, and what do you get? 2x plus 1, right? Now what do you multiply x squared by to get 2x? You can't, so that's your remainder. 2x plus 1 over x squared plus x minus 2, right? Y'all with me? So this integral is actually the same as the integral x minus 1 plus 2x plus 1 over x squared plus x minus 2. That's the same integral, right? And you have 3 separate terms here, right? This, and this. You can find the antiderivative of x, right? 1/2 x squared. The antiderivative of 1? X. Now this one,
U equals x squared plus x minus 2.
that's it. Look, basic u substitution. Let u be the denominator. What's the derivative of u? 2x plus 1. It's right there up top. So you just have 1 over u du. That's a basic u substitution. Okay, I'm not going to do that anymore. All right. Matthew B. How's it going? You all right? You ready for the next one? I'm in no way trying to like embarrass anybody or humiliate anyone, so I hope you're not feeling that way. Number 6, we cannot do. Or can we? All right, Matt, you're not going to do this one, okay? I am? I am? Nope. Nope, it's not. But it will eventually be on a test. Yes. So look at this one. Check this out. Just tell me what you think of this. U is x squared plus 3x minus 1, right? So du would be what? 2x plus 3 dx, right? I don't have 2x plus 3, do I? I do not have that. Right? It would be really nice if I did, though, right? Wouldn't it be nice if I had that up there? Do y'all agree? I think I'm going to show this to you, but at some point I'm going to have to stop because it's going to require something we haven't done, for sure we haven't done. But I'm just going to show you the next step because the next step is algebraic. It's something you can follow algebraically. It's not a new technique. So we all agree I'd love to have this up there? I would love if the numerator was 2x plus 3, right? I would love that. Okay, so watch this. Here's the integral. Out here I'm going to put 1/2 times 2 over 1. Do you all agree that that is the same thing? Right? Now I'm going to multiply this 2 through and leave the 1/2 out there. So my numerator is going to become what? 2x minus 8, right? Okay, now I need it to be plus 3, so watch what I do now. I'm going to add 3 and subtract 3. Okay, now just follow me through here. We have a 1/2 out here. I have a 2x and a plus 3 right there, don't I? So this is 2x, this is plus 3, and then this is minus 11. Do we agree with that? Okay? So I did like a very tricky kind of, like I put these two together and then I just put those next to one another. Now what I'm going to do is I'm going to split this into 2 integrals. The first integral I'm going to have is 1/2 integral 2x plus 3 over the denominator x squared plus 3x minus 1. The next integral I'm going to have is minus 11/2 integral 1 over x squared plus 3x minus 1. So I split it right here. So I put the 1/2 with that on top of that, 1/2 that on top of that. Then I did the minus 11. I brought it out of the integral. Minus 11 over 2, and then I have 1 over this. You see that? Okay, this one is a basic U substitution. U is the denominator, du is on top. Agreed? So this is going to turn out to be like 1 over u du. This is the natural log of u. This I can do now, right? This one, I'm going to have to just time out, pause, we come back, I'll show you how to do that, all right? This we can't do yet because it doesn't factor. If it factored, it would be nice. It doesn't. So we need a new technique for this. And just a little heads up, we're going to complete the square on this. That's what we're going to do. We're going to complete the square in the denominator, then it's going to get us to a formula at some point. Okay, that's where we're headed. This was on this test, which means they covered a lot more material on this first test, right? I think in this spring 2015 test that I gave included more of the techniques than y'all have. All right, next one. And I didn't forget about who's up? Who was up? It was Matt, right? Yep. Sorry, you thought I was going to forget about you. All right, Matt.
I forgot about him.
Wait, you didn't do? You didn't do one? Okay, so you'll get this one. You get this. You'll get the next one. Okay. Thank you, though. Thanks, Hugh. I'm sure he appreciates that. All right. So are you thinking integration by parts? Okay. So integration by parts, you're wanting this to be your u, so that when you differentiate it, it's going to go away. Yes? Now if you do that, that has to be your dv, right? Which means you have to integrate that. Are you comfortable integrating arc sine of x? Not integrating it, that'll be tough. No, it's all right, don't. Okay, so what would be your other option? If this being your u does not seem to be helping you because you can't integrate that, what if you reverse the roles? Okay, so what if this was your u? Do you know its derivative? Or do you know where to find its derivative? It's on a formula sheet, right? And then this one you would integrate. That one we could do, right? And let's just see what happens. So we have to do arc sine of x here, and dv would be x dx. What is the derivative of arc sine of x? 1 over square root 1 minus x squared dx. And then here, when we integrate this, up to here, 1/2 x squared, right? And then our new integral is going to be this, right? That's our new integral? And that new integral is something we can't handle right now. Sorry. No, because this is x squared, and if you let 1 minus x squared be u, then dx, it's not going to happen. But it can happen later, all right? Look, the first step, though, this is the correct first step, all right? We're going to have to just wave our hands at this one. Oh, this one, number 8. Oh, this was a killer. Okay, so no one say anything. You ready? No one say anything, all right? What was your name again? Adam. Adam is up. If you tell Adam what to do, then I'm going to take off 10 points on your exam.
Oh my god. You can do it, bro.
This was the most common missed problem on the test. Can I help you a little bit? Don't overthink this.
Could you get rid of the square root on the bottom?
Nope. How would you do that? Just square everything? I think we talked about with an integral, you can't just like square top and bottom. You can't do anything algebraic like that. Don't overthink.
And I see that the derivative, like it would be, it goes x, 3x squared, and then 4x, and then minus 7.
So what about that? I'm not sure what you're saying.
Yeah, well, I mean, I'm just saying that I see it, but I'm not sure, like, what to do with it.
Okay, you're saying 3x squared is what?
Well, that's like the derivative of the bottom.
Oh, of this.
Yeah.
So you're telling me that you see something in its derivative?
Yeah.
Is that exactly what you're telling me?
Yeah.
Okay, so what method is that when you see something in its derivative?
Substitution.
Okay, so what are you going to use as your u?
Just the entire bottom.
That's right. Well, with the root or without?
Without.
Without. Okay, there you go. That's it. If you just let the entire radicand, what's underneath that radical, be u, the derivative of it is exactly what you see up top.
That was the most missed problem.
This was the most missed problem, yes. Okay, so that, well, because I think by the time students got to that, they just assumed that this was going to be the hardest problem on the test, and they just kind of gave up trying to think it through and made it a lot harder, tried integration by parts, tried all these different crazy things, when it's just something in its derivative. So this just becomes 1 over what? Root u du, and that's the integral of u to the negative 1/2 du, which is 2u to the half plus c, and then just plug your u back in. So your answer is 2 times the square root of this plus c. Okay. Let me see, is there anything else here? There was no bonus there.
Oh, they didn't get it.
I was about to
I might put a bonus on there.
I think it's like
I think practicing what measurement is like the best way to just
Practicing what?
just like practicing like figuring out which method to use is like the best way to I don't know.
To prepare?
Yeah.
Yeah, because that is really, like I said, the thing that really causes problems is knowing what you're supposed to use. And that's just you looking, identifying. I don't know who, your hand up?
Is it just gonna be less than 10? Problem.
It should not be more than 10. So that means what our class is 100 minutes long. So you're looking at about 10 minutes per problem, roughly. Yes.
That last test you showed us, you said that was the hard one? That was the hardest one.
That was hard. Well, there was more techniques on there. See, because remember, there was a few that I didn't do, like didn't finish, right? The techniques to finish those are a little more involved. So, yeah, let's see. Haven't really looked at anything more here.
What about the spring of 2017 exam?
It was just the same. Is the same review. The review was the exam that y'all looked at. So. Fall 2018. I don't have that one. I have to write it first. Let's see. I see 2004. This is fall 14. I haven't looked at these. Oh, this is. No, that didn't say take home. No, this is not. Okay, so this is an exam from fall 2014. Let's see how many of these we could, and we're not even going to do them. We're just going to talk about what to do. Anyone know what to do on this one? Integration by parts. What's U? The arc tan of 4x. dv? dx. This one.
that's your
U sub, what's your U? X squared minus 1. Derivative of that is 2x. This one is not within grasp for us yet. Because if this was 2x, we'd be in business. If this was even x cubed, we could do it. But because it's x squared, we actually need something else that we haven't done. So this fall 14 exam, we had covered more stuff.
What is it called that we would have to use?
On this one, we would have to use trigonometric substitution. Long division first, but you're not going to have a problem like that. Yeah, this. Okay, so I'm skipping these because these are still out of grasp for us. This one is within grasp. Basic U sub. What's U? ln x. The derivative is 1 over x. It's sitting right there.
Oh, that's one of our
Integration by parts. What's U? That's dv. So in the new integral, 1, right? And then this one, new integral, tangent. And then you have to be able to integrate tangent. And do you know the antiderivative of tangent? It's on your formula sheets. Okay? You'll look it up. The antiderivative of tangent. It's like natural log of secant x or something like that. Oh, here we go. We just did this one. U is x squared plus 4. I think, Bianca, we just did this one, right? You did that one a second ago? Yep, so we just did that one. Oh,
Back again.
it's back. It's rabbit out of the hat, right? And a bonus. Integration by parts. U is the natural log of all that stuff. dv is dx. And then you make your little table and see what that new integral turns out to be. And I just brought this up just to see.
If we do some of the bonus and we get kind of.
Bonus has to be right. Yeah, the bonus has to be done correctly and completely. Yeah, no, there's no partial credit on the bonus.
Yeah, but I like that a lot better than the.
Let me see.
That should be our exam.
You know, my old computer, I have exams that go back a lot further than this.
How far back is it?
2001.
How long have you been a professor?
I've been doing this for a long time.
Did you have to use Windows XP? Or no, something older?
I'm pretty sure I lived through Windows XP. There was a time where I was using Word Perfect. Not Word.
Was it perfect?
It was no good.
Used a typewriter.
I used typewriters, yeah. No, I didn't use typewriter. All right, well, I think that's probably, I mean, at this point, you're, what, less than 48 hours away from the exam, so here's what I can tell you. I mean, I'm going to keep the problems within the scope of the things I've shown you, all right? You know, a lot of students will say they come, they take the test, and they're like, that was nothing like the homework, or that was nothing like the problems he gave us, and that's because they might be a little different, okay? Just because they're different, if the techniques are still the same, you know, as long as I'm not asking you to do something I've never asked you to do, I think it's fair. So you should be prepared for all this stuff, right? Do you have any questions? Yes?
Are all the questions going to be for immigration, or you have some that are just derivative or hyperbolic?
Yes, there will be. I would say the test is probably 90% integration. But there will be some stuff where you have to take derivatives of the inverse hyperbolics. And like I showed you in the very beginning, there might be some where you have to verify an identity for hyperbolics, a little bit of chain rule or product rule with hyperbolic inverses. So you got your formula sheets, which remember, bring your formula sheets. I won't provide them to you. You can't use your phone during the test to look up things on the web, right? Bring your own calculator, although I don't really think you'll need a calculator. All right.
Bring a unit circle just for a safety blanket.
If you want to put it in your bag, you can, but you can't have it out. Yeah. All right. Is that it? Okay. If you go into Canvas, you go into Files, there will be formula. I think it says like formulas you can bring to the exam. Just open that up, print it. It's like 5 or 6 pages. All right. Well, I'm cautiously optimistic. That means I'm feeling good about the test for you all, but I'm cautiously feeling good.
Can I get a phone?
You can come to my office.
Oh, okay. So
Yeah, I don't carry them.
when do you...
They're on Canvas.
Oh, okay. Oh, is that how everyone got them? Like,
Yep.
printed them out?
Yep.
Oh, okay.
Yep.
I wasn't here like for
Yeah.
3 days, so I didn't...
Yeah, no, in Canvas under Files. Yep, there's like 5 or 6 pages. Print those out. All right, let me turn off my camera here.
You said you'll get bonus for the study groups? Is that on?